right, we're going to be looking at doing the CAM of this 2022 paper 2 matric question. They've given you this corner P over here to start our game with. I'm going to read these instructions over here first, and then we'll go back to actually reading what it asks over there. It says, instructions: from the corner P, draw a rotational scale of 10 millimeters is equal to 30 degrees. Okay, so let's start with that part. I'm going to draw a construction line coming out over here, and I'm going to then draw another construction line going out at a funny angle over here. Right, any old angle there. I'm going to measure off very accurately 120 millimeters. If I say I need 12 little 10 millimeter gaps, 12 multiplied by my 10 will give me 120 millimeters. So I can draw in, I'm just going to draw that in a bit darker over there. That distance from P to there is 120 millimeters. I then take my pair of compasses set to any radius, and I mark off on this angled line over here 12 little equally spaced little segments. Okay, let's just get that right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you could say, well, it's 10 millimeters, I should just be able to mark it off. Just be careful, they have said down here, show all constructions, and sometimes they give you marks for that construction, so make sure that you put it in there. I'm now going to take my two set squares and line them up over here. That line over there with that last mark that I made, and I'm going to draw in some lines going from there to there. I'm going from there to there. I'm going from there to there. I'm going from there to there. And we just keep on going across until we've got the 12 equally spaced 10 millimeter gaps that we need on this baseline of this graph. And it takes a little bit longer. As I say, they might be giving you marks for that, and you'd hate to lose out on such easy marks. Oops. If you have that problem where you've messed up, just get it nicely sorted out, slide it, and there we go. Right. Okay, once you've got that, take your set square. You're now going to do the next little easy marks thing. You need to label this, so I'm going to go 0 degrees, 30 degrees, 60 degrees, 90 degrees, 20 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, 360 degrees. Right, once you've got that in place, label it. They've asked you to label this graph, so you write in over here, displacement, displacement, displacement graph, Gr12, and underneath that they say that you need to put in the scale, so write in scale is CALE 10 millimeters is equal to 30 degrees. Right. We can now draw a line going up over here, and you need to label that as displacement d I s p l a c e m e n t in millimeters. Right, okay, once you've got that in place, you can then draw some construction lines going up over here from all of these intersections to give you your 10 millimeter gaps. And then we read what they want you to do. It says, the follower, the cam imparts the following motion to the follower. It is at rest for the first 60. Right, so I come along here and I draw in dark from there to there. It is at rest. It's not moving up or down. Right. It then says it rises 80 millimeters with uniform acceleration and retardation over the next 150 degrees. So 30, 60, 90, 120, 150. Okay, that would be that line over there, and that 210. I'm just going to highlight that line a little bit. Okay, so that line over there, we're dealing with that line over there, and we need to measure off 80 millimeters up. Right, take my pair of dividers, and I measure off 80. Come over there, and I'm going to mark off 80 millimeters. Right, that point over there is where I need to take my next story. Okay, right, it's uniform acceleration and retardation. I think the first thing to do is to break it up into how many spaces? 1, 2, 3, 4, 5. Right, so I draw a line going out here, and I will mark off 5 spaces on it. 1, 2, 3, 4, 5 spaces, right? And then take my 2 set squares, and I'm going to line that up over here. Oops, what's going on here? Seems to be a bit of a bump on my desk. Right, let's get that right. Line that up nicely with the story over here. Got that in place, and I can now slide that back. Okay, so that's 1 space, 2 spaces. There we go. That's it. Okay. Right, I'm going to I need to take this across over here. Just going to highlight that line over there. And we need to find the midpoint of this. The way that I'm going to do that is I'm going to take my set square and find the midpoint. Let's just do, using a 45-degree set square there, draw a line from that 60, draw a line from that 120, and that will give you the midpoint between the 120 and 50. Okay. I also need to find the midpoint between this 80 millimeter length over here. So I'm going to draw a line going down at 45 degrees over there, and a line going down up at 45 degrees over there. I can now draw a line coming across over here, and that gives me a very important point over there, because your acceleration is going to go up to that, and then it's going to retard over there. Right, so what I need to do now is to draw some lines coming out from that 60 to that first gap over there. See that little gap over there? Draw a line coming out, and you can see that point over there is the point that we need. And I'll draw a line going from that 60 going up to that point over there. And my second point is at this 120. Okay, so I'll have a curve going up like this, up to that point over there. And I'll need to find these points. I'm going to take a line coming across over here to there, and a line coming across from there to there. Okay, so those lines coming across to this line over here. I draw a line coming from that top point over there down to there, and I have that intersection over there, and I'll draw a line coming down from that top point over there to there, and I have that point over there, which means that I have this curve which is going to come down all the way down to there. And once I've got that in place, I can take my pencil and draw in that curve of acceleration and retardation. Okay, after that, you can see that it says over here, it returns to its original position with uniform motion over the rest of the rotation. Right, so I'm just going to draw a straight line going all the way down to that 360. And that is all you need to do for that question. Super.